Hi there, I'm Jackie Lynch, and I'd like to thank you for taking the time to listen to this session where I'm going to be sharing my thoughts about what I think about cloud. I'm going to start with somewhat of an introduction and talk about some of the concepts and benefits. Then we'll look at some deployment options, and we'll talk about what you need to do to prepare for moving into the cloud. And we'll also talk about some of the risks and benefits of going into cloud. And then I'll end with some final thoughts. So let's start with the introduction and some concepts. So it's a little hard to define cloud computing because everybody has their own view of what it is. The National Institute of Standards and Technology has one idea, which is that it's a model for enabling convenient on-demand access to a shared pool. The purpose of cloud computing is to provide computation software, data access, and storage services that don't require that you, the user, know where it is, what the configuration is, and so on. And it's really a natural evolution of virtualization, SOA, and some of the utility and autonomic computing offerings. Cloud systems have several different key characteristics, and they range from agility, being lower in cost, device and location independence, multi-tenancy, and all the other options that you see listed here. They take advantage of things like application programming interfaces or APIs, and if they're correctly set up, they have the ability to be scalable, provide good performance, but still be secure. And we're going to touch on a number of these characteristics as we move forward. There are a number of reasons why people are considering going to cloud, and one of the primary ones is the reduced cost. You have the ability to reduce both capital and operating costs, or moving capital into operating, and you only pay for resources when you're actually using them. It also allows you to refine how you use people. So instead of having people maintaining hardware and software, maybe you could free them up to focus more on the business or some of the new technologies that you want to integrate in. Cloud is also scalable. You can add resources, you can remove resources, which is what makes it flexible. If it's properly designed, you should have good disaster recovery planning, downtime should be less, and you should be able to, by using self-service, do rapid deployment of test and development workloads. And of course, you can run your critical workloads on the cloud. So these are a number of the reasons why people are looking seriously at cloud. Let's talk a little bit about concepts. The first concept is virtualization, which most people who've worked on power systems should be familiar with. That's the ability to have many servers or output paths, share resources like I/O adapters and CPU, etc., and they can share them among many customers and clients. The concept of scalability we touched on already. That's the ability to add and remove resources dynamically and in a flexible manner. Manageability is one of the key things that people look for in cloud. The ability to rapidly get a new environment provisioned based on demand, and of course remove environments when you don't need them. And that comes down to service automation management. And you want it to be pervasive, which means that you want all your services to be delivered to any platform that you can put in that cloud. And of course, finally, we have the concept of flexible pricing, which is typically meaning pricing that is based on your usage, not necessarily on what the resources are that you have available. When I look at cloud, I think of it as having three different layers that I can pick from. And the first one is infrastructure, or infrastructure as a service. Basically, the virtualized platform is delivered as a service. So, for instance, you'll get a virtual machine or an LPAR. The cloud provides the physical assets such as servers, network devices, disks, etc., and you have to do the rest. So you would put the operating system on and you would take care of maintaining that operating system. The second layer is an improvement on IaaS called Platform as a Service. And this is where you have all the resources that we talked about before, so you'll have your virtual machine, but then we also add the solution stack and all of the middleware that basically makes it much easier for you to deploy applications. It will provide the application infrastructure, but you will still have to provide the application itself. The third and final layer is the application layer, or what we call software as a service. And this is where everything is delivered as a service. A classic example of this is something like Salesforce. The applications are provided by the actual application provider, and they take care of things like upgrades, etc. This is a great diagram that compares on-premises with IaaS, platform as a service and software as a service. And it shows you the different environments, what you have to manage and what the vendor will manage. And as you can see, the further you go into the different layers, the less work that you have to do with respect to managing technology. I also like this diagram that I found that compares the cloud services to a pizza. The difference between made at home, take and bake, they deliver it, or you actually dine out of the restaurant. So the concepts are the same. So it's an interesting comparison. There are also a couple of different virtualization models. The first one is ASP, or Application Service Provider, or a traditional, typically SaaS provider. We're looking at dedicated servers or LPARs for each application. We have to use them where regulations require that they be dedicated. So we don't have multiple different clients on the same LPAR. Multi-tenancy is where there's a single instance of the software that serves multiple clients, and when you're in that environment, you need to look at issues like data privacy, how you get customizations made, and so on. Then we have what I tend to think of as virtualized, which is where I either have operating system or hardware virtualization. So when we're talking operating system virtualization, we're talking VMware, we're talking Xen, we're talking the Amazon AMIs. When we're talking hardware virtualization, we're talking about the Power System LPARs that run under Power VM or KVM LPARs. These are typically used for single tenant applications, and you can have multiple tenants on the same server in different LPARs, which gives you that level of separation while taking advantage of the physical resources. If we look at the traditional ASP environment, you'll see that each tenant is in their own environment. So tenant 1 has his own presentation layer, business layer, data layer, and hardware. So we get the separation that we want to have, but obviously it's going to take more resources because there is no way that they can share things. The main advantage of an ASP model is that you don't have to redesign anything that you're currently running. You still get isolation, you could do a lot more customization, and your backup and disaster recovery is going to be per tenant. But you have very poor scalability, and obviously it's more expensive to run because you have to provide more resources. The virtualized model, on the other hand, still allows you to have the separation of tenants. They're each in their own operating system, but they can be running on the same hardware, and they can take advantage of things like the shared processor pool. They can share Ethernet adapters and fiber adapters and still have the level of segregation by running in their own virtual machine. Again, there's no application redesign needed, and you get the isolation. You can have the hardware and OS customizations that you want, and your backup and DR is still per tenant. So it's much better than ASP in terms of scalability, but it's not as good as shared middleware. And there's a higher administration overhead than doing full sharing because you've got to have administrators for each of the environments. We talked a little about this earlier, but there are a number of reasons why people want to go cloud. I talked about cost reductions and the fact that it allows people to move costs from capital to operation if that helps them out. Also, if you get the right environment, the technology upgrades are done by the provider. Even if you're only in an infrastructure environment, they take care of upgrading switches, servers, and so on. You can get enhanced security, and if you can get higher performance per core if you actually design things correctly. And then finally, we've got availability and scalability. In the cloud, you should be able to do elastic scaling to whatever the limits are of your application. And availability should be designed into the cloud so that you should take zero planned downtime whenever possible. You really can't have cloud without having automation. It's critical to cloud. It's required if you want to be able to scale. It's what provides you with the level of standardization that makes it easy to add, grow, and shrink environments. It gets rid of manual intervention and therefore potential errors. And it's very helpful when you're going through audits and process governance because the automation provides the audit logs and so on. Basically, automation is about getting things out faster and helping to maintain quality. Another two concepts are provisioning and elasticity. Elasticity or scalability, that's the ability to start and stop instances as needed and to pay only for what is used when it is used. Provisioning is the automated maintenance of configurations, the ability to add and remove resources dynamically when you need them, and the ability to manage changes. And then finally, one of the things that a lot of people want, particularly with their test and development environments, is instant provisioning. And that's something that should be provided by any cloud that you are looking at. So there are three key deployment options for cloud, and we're going to touch on those now. Cloud deployment options that most people will be thinking about are private cloud, public cloud, and hybrid cloud. So a private cloud is basically everything's within your enterprise and behind the firewall, and you don't share it with anybody else. It's for your IT and your business only. Public cloud is where all of the IT activities and functions are provided as a service over the internet. And then hybrid cloud is when you integrate some private and some public. So there may be certain things you have to keep on-prem or in a private environment, and there are other things that could be out in the public cloud. And so a lot of people are going hybrid cloud, which allows them to architect the best of both into your environment. So as I mentioned, private cloud is used solely by your organization, and it lives completely either in your data center or if you've outsourced in the outsourced data center. It's typically managed either by people within your data center or by a third party that you subcontract out to. You can have hosted private clouds as well, which I mentioned, and they can be hosted and managed by a third party, but they're for private use only. And then our hybrid clouds are where we do shared cloud services. So parts of the cloud will be shared with other customers of the service, and it's typically two or more clouds that interoperate together. And then finally, as I mentioned before, we have public cloud. That's stuff that's available to the general public. It's sometimes called an external cloud or IT as a service. A couple of other things to mention about private cloud, which is also called internal clouds. Typically, everything is within your corporate firewall, or if you're outsourced within that data center's firewall. There is no multi-tenancy. Everybody on those systems in that cloud is related specifically to your business. So it lets you do some sharing while you maintain your data security, governance, and reliability. And it gives you control, but only some of the savings that you would get from public cloud. Public cloud is fairly easy to do and relatively inexpensive. All the hardware, bandwidth, and application costs are covered by the provider. The pricing is typically flexible, and really IT does become a service. But it requires that the environment you want to run in can function in a dynamic provisioning and automation type environment. And then hybrid cloud, this is one of the things that allows you to transition to cloud, but you'll still maintain your PCI and other regulatory compliance. So things that have PCI, etc. rules, you could keep on your private cloud within your data center and put the things out in the public cloud where you don't have those kind of regulations. Basically, you're placing services where they can meet the requirements for compliance and performance and scalability and so on. It gets you a lot more of the savings over private cloud, but gives you some of the security, etc., that you get with private cloud. And another term is multi-cloud, which is really where you're using more than one cloud service from more than one cloud vendor. So you could combine multi-cloud and hybrid cloud into a hybrid multi-cloud. There's a lot of different options for what you can do. When we look at cloud, we see several different areas. The first thing is the client. That's typically the computer hardware or software that depends on the cloud to deliver the applications. Then there's the actual applications, which could be software as a service or cloud application services that deliver the software over the internet. We have the actual platform. So that's the computing platform along with the solution stack. We have the infrastructure, which is where somebody gets given in a virtualized environment, but they have to be responsible for the actual operating system and so on. And finally, we have servers or LPARs, which are hardware and operating systems. And you should see all of these things within a cloud environment in various places. So infrastructure as a service, this is the one I talked about earlier that gives you the computer infrastructure. It's typically going to be a virtual machine. It usually has utility computing options and cloud computing options. So you should be able to add CPU, remove CPU, add disk, remove disk, same with memory. And that kind of provisioning should be very easy to do. You own all the security and you own the operating system and the applications. So you still have to have people that are able to support those. Platform as a service takes things a step further. You get not just the computing platform, you also get the solution stack. It saves you having to buy and manage the hardware and software. So they will provide you with the hardware, they'll provide you with the operating system, the middleware, and the application runtime environments. And then you just have to provide the applications, support and maintain those applications. Software as a service is where the vendor actually just delivers you the software over the internet. You don't install and support and run the applications. It's usually pay as you go. It is typically multi-tenant, which means that other people are using the same environment that you are using. And the SaaS provider manages the environment, all the upgrades. If you need customizations, they would manage that. But if you're in a multi-tenant environment, it's much harder to get those through. And it's very easy to request new environments to test things. So basically, as a consumer, you're focusing on the application and not the infrastructure. And all of the security is the responsibility of the cloud provider. Now that we have most of the basic concepts and terminology, let's talk about what you have to think about when you're preparing to move to or thinking about moving to a cloud. First step's always going to involve analyzing existing processes and applications, because what you have to look for is what can be automated. Without being able to automate things, it's very difficult to move into the cloud. Automated approvals are also critical, so you have to be able to delegate capabilities. When you're provisioning resources, there should not be any requirement for manual intervention. And that's part of analysing the processes, is you've got to identify and remove any manual approval steps and identify security and compliance needs so that you can figure out what you can and cannot move into the cloud. As you move into architecting your cloud environment, you need to think about what are the things that you've got to have. Are there specific monitoring tools and standards that you have to have? What kind of reporting has to happen, and particularly for things like security and audit? How does capacity planning work? Do you have a service catalog that you can pick from? Data protection is something I'm going to go into in more detail. But you also have to look at security and what policies do you have and how do you plan to enforce them, and preferably automatically. And then you need to look at the skills that the people who are running the cloud provide, as well as the skills that you may need to bring to the table. And of course, there's billing and cost allocation methods and tools. What options do they offer you, and which ones are the best for you to take advantage of? Most of the concerns about cloud have to do with security. The first thing that I had a concern about was the lack of visibility and control. You can't see really into the cloud. You don't have access typically to the HMC. You don't have access to the VIO servers. So the only access you really have is to the actual virtual machines that you're running. Additional concerns people have to do with the protection of sensitive information. And that's really, I'll talk more about that in privileged user access. Where is regulated information stored and how is it managed externally? These are all questions that you need to think about. So when it comes to privileged user access, you need to look at how sensitive data will be protected and who will have access to that data. And in particular, who at the cloud provider has access to your environment, what access do they have, and where are they located? Can they actually get to your data? These are all questions you have to be able to answer. And then we have regulatory compliance. There are external audits and security certifications that are going to be required depending on your business, and they should be conducted regularly to ensure security integrity of data in the clouds. So you need to know what your cloud vendor will and will not allow you to do. And that's why I'm concerned about lack of visibility and control, where you can't see HMCs and VIO servers, because if somebody can break into those and you don't maintain them, then can they get to your systems or break your systems? Data location is an interesting one, because one of the things people always tell you about the cloud is you no longer have to worry about where your data is. Well, actually, you do. Different countries have different laws. Local authorities' privacy laws and jurisdictions, etc., actually matter. In Europe, the privacy rules are much stricter than they are here. So if you put your data in the cloud, you actually need to know at a minimum what country that data is actually going to end up in, and is there any chance that it will end up in another country, based on DR and so on. You have to look at the data and figure out what segregation you need to do. Is there certain data that needs to be encrypted, and particularly when you're looking at a multi-tenancy situation. Recovery is another thing. You need to know how the backups work and how data recovery is going to be implemented in the cloud. It's really important to understand that, because they may be taking backups, but if they lose the server that the backups are on as well as your server, how do you get your systems back? And then security scans and audits. So if your security department requires them, who runs them? Is the cloud provider going to do them for you when you request them? Are you allowed to run your own scans? Can you use external companies to actually do regular security audits, which a lot of people do? And then, of course, we have the issue of ransomware protection. You want to make sure that if they get broken into by really bad guys who install ransomware, that they have the capability to get your data back for you without you having to pay these massive, bribes, for lack of a better term. Let's talk a little bit about what's involved in implementing a secure cloud. And the first thing is, you've got to have policies. You have to implement and maintain a security program. You have to know how it's going to be enforced, and then you have to implement auditing and make sure that the policies are actually going to cover the things you need to have covered. You need to have good firewall configurations and server security, and then look at roles and who should have access to what. Confidential data has to be protected, and you need to know the location. Implementing strong access and identity management, typically that's going to involve something like LDAP, but you want to make sure that people don't have access to things they shouldn't have access to, and that when they log in, they really are who they say they are. We've talked about provisioning earlier. That's part of having a secure cloud. And I already kind of alluded to having a governance and audit management program. It's very important to have a vulnerability and intrusion management program, and on top of that, to understand if the vendor is providing all the environments, how do they deal with the stuff that comes out from CERT, the CVEs, when and how often do they implement security patches, etc., and particularly on things like the VIO servers. And then, of course, you need to maintain testing and validation environments so that you can go through the various steps that you would normally go through before things go into production. With respect to software and service delivery, I've already talked about how you need to know where your data and services are, and that's something that they should be able to tell you. You need to know for your data, is it required to be located in a specific country? Is it not allowed to be in certain countries? And then the same question about the support people. Who supports these environments? Who's going to have the ability to log in and recover them, and so on? Obviously, response time is part of software and service delivery, both response time for the applications, but also response time when you have a problem or you need to recover something. You want to know what the guaranteed response times for those are. System management and maintenance planning is also really important. You need to know how much notice they would give you for a maintenance situation. And then proactive communication. This is the notifications regarding outages, maintenance activities, and so on. And finally, think about system monitoring. What are the key performance indexes that you need to be monitoring, and make sure that those go into any service level agreements that you have with the vendors. We talked about scalability earlier. It's basically the ability to respond to high volumes of services during peak and lots of requests for services that are not necessarily regular. The ability to expand the system with minimal cost and then reduce it back down so that you still get consistent service quality and system performance even though volumes may have grown. And you want those service requests handled automatically. And then part of scalability is knowing how often the vendor does technology or performance upgrades, because you want to make sure that you're positioned to take advantage of those. High availability is also another key component. You want to make sure that any facility you're dealing with has reliable and redundant power, cooling, and a network infrastructure, and preferably not in an area where they flood or have other major issues. You want to make sure the infrastructure, such as networking, servers, software, etc., are highly available. And make sure that you thoroughly understand the disaster recovery offerings that they have. Because sometimes they have multiple offerings based on price, where you can get local DR for X, you can get same side of the country for Y, and if you want it on the complete opposite side of the country, it's X times Y or some other dollar value. Make sure you understand what the options are and what the risks are with each one. You want to make sure that they have 24/7 operational capability and clearly documented failover and disaster recovery plans, and that you understand the implications of different kinds of outages, whether they are local, regional, countrywide. So these are all important questions to think through and ask as you go into this environment. Which leads us into a discussion of the risks and the benefits. So in terms of the risks, obviously the first one's going to be performance. What happens if the provider runs out of resources and they can't provide you with enough bandwidth? I had a situation in a cloud where I needed more CPU, and they didn't have a server that they could move me to give me the additional resources, and told me it was going to be 6 weeks. That's not dynamic performance growth to me. So you need to understand whether or not they have available resources that they can quickly provision you with. What's the impact of mishandled data? If something happens to your data, what does that mean? The other thing you will have to keep an eye on is all the service charges, from the metering and monitoring, and making sure that they are actually billing you correctly. I've seen the next couple where a vendor went into financial problems or had legal problems, and one of the government regulators walked in and shut them down, or where they had operational problems. So what happens to you if that happens? Think about that, because it has happened to some of the vendors in the last few years, and you need to make sure that you are covered for that. Obviously, we have data recovery and confidentiality problems and just the general security concerns and governance. And then you've got to think about PCI, HIPAA, and all the other regulatory compliance. The other risk is lock-in. If you go with a specific cloud provider, you may not be able to move your applications and data somewhere else. How portable is the data and those applications? These may not matter to you, and that's fine, but just make sure that you do understand the risks that each one of these brings. And of course, risks are offset by benefits. So from a business perspective, the cloud should be able to provide you with responsiveness and agility to deliver new solutions, which of course translates into hopefully a decreased time to market. It should give you more mobility for your employees who should be able to access these environments from anywhere, from anything. It could be an iPad, it could be their phone, it could be their laptop. With incremental pricing, that means that you can get availability without capital outlays. Again, this is what I talked about earlier with the ability to move costs from capital to operational. It also allows you to adjust the volume of users when the workload increases or decreases. And of course, you get new product releases automatically and at no additional cost. But just remember, you want to know when that's happening, particularly if it's going to change the look and feel of the application that all of your customers or clients are using. From an IT perspective, there are also some benefits. The first one is that IT no longer has to focus on hardware. Instead, they can choose the areas that they focus on, where perhaps they can look at emerging technologies and how to integrate those without the high risk and cost. You can leverage the service provider's expertise so that you don't necessarily have to have some of the specialized expertise in-house. And of course, it lets you optimize any investments you have in your existing infrastructure, because you can keep that to do other things while you put other things in the cloud that don't need to be on that existing infrastructure. You usually see a reduction in capital, but you will see an increase in operational. But the one thing that you cannot forget is when it comes to your applications, you are responsible for testing and QA work and even performance testing before things go into your production environment. That is not something that the cloud vendor will do for you. Now, if it's software as a service, that's a little bit different. But general cloud, you need to be doing these things. And for software as a service, you need to make sure that they are doing these things. Below is a short list of some of the questions that you might want to think about asking yourself before you start moving to the cloud. And they range from, do you need to rapidly bring services to market, to what are your resource constraints, how does your testing work, what do you need for provisioning. And to me, some of the more important ones are do I have a plan to switch back from the cloud if this doesn't work? What happens if the cloud goes down? Am I going to be locked into this cloud vendor? And then looking at it going, will a single cloud meet my needs? Do I need multi-cloud? Do I need to keep some things on-prem and put some things in maybe a private cloud and some in a public cloud? So these are all questions you need to think about so that you can properly structure what you plan to do within the cloud. And of course, a proof of concept is always highly recommended. 2023, SANS actually did a survey, and they found that more than 45% of applications were not cloud agnostic. So that meant that they would need significant work in order to be able to be moved into a cloud. That's one of the questions you need to ask yourself. Are my applications cloud agnostic? Is it going to be easy to move them into the cloud? This is a slightly older survey from 2019, and it was a survey that was done on multi-cloud management. And basically, 93% of the 300 decision makers that they surveyed said they were using multiple infrastructure clouds for their business operations. They also talked about their primary reasons were automation, analytics, and governance, and they needed to find a balance between agility and cost. So this was a very interesting survey, and again, 86% of them were actually expecting to look at containers, microservices, and Kubernetes in the coming years. So for 2024, Synergy Research Group published the results of a survey. This is based on Q1 2024. And they're just showing what percentage of the cloud environment the various vendors have. So as you can see, AWS and Azure are really the top two, with several other cloud vendors filling in the rest of the table. And the thing that was really interesting was that cloud infrastructure service revenues just for the first quarter of 2024 was $76 billion. So this is an environment that is not going to be going away anytime soon. Flexera did a survey in 2024, and they looked at 753 cloud decision makers, and they found that 89% were multi-cloud. Of those, 73% were hybrid cloud, 14% multiple public cloud, 2% were multiple private cloud, and then there was 10% who were single public cloud and 1% single private cloud. And you can see the breakdown of the reasons and challenges that they had down below. But the number one challenge was understanding app dependencies. And that was one of the questions that I had for you to ask right up front is, can you automate your applications? What are they dependent upon? That's a really important question to answer. So I also asked them, what public cloud providers did the organizations use? So you can see them listed down here. Basically for AWS, and they've broken it down into running significant workloads, some workloads, experimenting or planning to use them. And you can see that they really, all of them, had some level of all four of those. Flexera also asked them about their use of AI or Gen AI public cloud services, and also questions about cloud cost optimization and sustainability prioritization. And again, here you can see the numbers for what those were. SANS 2023 survey also looked at what percentage of workloads were running in the cloud and which cloud service providers people used. Out of 245 respondents, 86% were using multiple cloud providers, and AWS, as with the other surveys, was still the leader in terms of the percentage of workloads running in the cloud. It was interesting that they actually asked them why did they go with multiple cloud providers. And there were a number of reasons, but the first one was security features and then availability. Unique service offerings was next. Some of them looked at what their developers preferred. Some of them looked at how good they could do with negotiating and so on. So this is a good survey to go and look at because you can see whether or not it matches up with what your thoughts are on how you're going to pick a cloud provider. People are quite often surprised about all the different places that clouds pop up in your life today. We have things like online games, we have Google Apps, things like Dropbox, Office 365, Box, Salesforce. All of the things listed on this page are all some form of cloud behind the scenes. So whether or not you like it, you are using clouds today. The only question is, from a business perspective, how do you want your business to integrate your applications into the various different kinds of clouds? So if you talk to a salesman, they're going to tell you that cloud is the answer to life, the universe, and everything. We're going to look at a couple of cloud myths that are out there and talk about what they really mean. So here's some of the myths. There's only one single cloud. All you need is your credit card. The cloud's going to reduce your workload and you can seamlessly blend your private cloud with public cloud vendors. You're never going to be able to blend your clouds. Cloud computing always saves you money. A cloud provider can guarantee security. If you're running virtual machines, you're doing cloud computing, and cloud computing is about technology. So all of these are untrue or true in certain circumstances. As an example, a cloud provider cannot guarantee you security because you're the one that's going to be responsible if it's an infrastructure as a service for the operating system. The ability to blend your private cloud with public cloud providers and it depends. You may be able to seamlessly blend it depending on the applications and how they were architected. And the saving money is also going to depend on how your environment is built and how flexible it is, how easily it integrates into a cloud, and how expensive it was. So these are all things to think about. And I just put a few comics in here that I thought that you might enjoy, basically stressing some of the things that I talked about. I particularly like the bottom one where the guy says, I'm not worried about cloud security. My data is so disorganized, nobody ever be able to find anything. So I hope you enjoy these. CIO magazine published their top 7 cloud myths. And again, they're very similar to that first list I gave you. Moving to cloud automatically saves money. The cloud is not safe for storing data. And you could read the rest of these. The cloud is difficult to audit. The cloud's going to kill all of our IT jobs. And of course, the one that I started with, a single cloud. That's all we need. Gartner in 2019 published their top 10. Again, they're very, very similar. The couple I want to point out is multi-cloud will prevent lock-in. Once I've moved to the cloud, I'm done. And I want to make sure you get that a plan to shut down your data center is not a cloud strategy. A cloud strategy involves an awful lot more than just we want to go away from being on-prem. You need to think about all the different things that are involved with doing so, and in particular pay attention to security and what happens if something happens to the cloud vendor. Forbes also published in 2020 their 20 persistent cloud myths that were stopping businesses from adopting cloud. I'm not going to go through these. There's a couple that are really interesting, such as IT loses essential control, it's insecure, the cloud is redundant and secure, the cloud is free and just works. I can guarantee you the cloud is not going to be free. And cloud security is solely the provider's responsibility. As you may recall from earlier when we talked about platform as a service, infrastructure as a service, and software as a service, who's responsible for security depends on which one you actually adopt. There was also a section in the study about cloud myths around VDI, or the virtual desktop environments. And the 4 most common ones were that cloud technologies were too complicated, they'd compromise security, the infrastructure is too expensive, and it harms sustainability. So those are all myths that they go into in great detail in the report that I provided the link for. And finally, some of the more egregious myths that we're all going to lose our jobs, that clouds are free or really, really cheap, and that performance is never a problem. As I mentioned earlier, when I went to add resources to one of the clouds that I was working in, there were no resources available, so performance definitely was a problem. The ability to replace Microsoft Office with Google or other cloud apps. There are certain things that some of the Microsoft Office apps do that aren't necessarily supported by some of the other cloud apps, and vice versa. So be sure to pick the one that meets your needs the most. Cloud is easy to set up and manage. That's going to depend on the cloud that you're moving to and what they require. Security is good. That depends on the cloud that you're moving to. And the last one I could tell you is absolutely not true. Moving to cloud mitigates responsibility for outages. Yeah, good luck telling the SEC that the cloud ate my data. You are still responsible for your business and for your business data and your business processes. The reality is that cloud is a complex resource and it requires a lot of understanding and hard work to manage it correctly, but when you do that, it can be very, very worth it. So now we're going to touch on some of the legal issues. So I already talked a little bit about location and use of data, knowing who's got access to your data and also where it physically is located. And this is partly because it's not just different countries. In the United States, different states have different privacy laws. So you need to understand what the laws are, where your data is going to be and where the data center is. You need to understand your obligations and you need to understand the provider's obligations and make sure that your critical things are in your service level agreements. which basically means looking at terms of use and reliability. Understanding the roles of all the people in the cloud stack. So what's your role? What's the provider's role? What are the support people at the provider's roles? And so on. There are legal issues around backup, restore, and disaster recovery plans. Depending on who you do business with, you may be required to have them, and you may be required to publish things like service levels. Obviously, there's a lot of legal issues around business continuity. If the cloud is down and you can't do business, how long can you last for? And what are the implications with respect to your own clients? And then, lastly, we have change control. Change control is really important, not just for the things that you change in the cloud, but the things that the cloud provider changes. And do you have access to knowing what those changes are ahead of time and then after they've been done? And some of the additional issues relate to things like exit strategy and lock-in and portability. Basically, if something happens to the provider, what are your options? Can you move your data somewhere else or copy it somewhere or back it up offsite? You also have to look at what are your electronic record retention requirements. How long do you have to keep backups and archives for? Are you going to keep them in the cloud? Are you going to keep them offsite? How do you plan to handle that? Can you get your data and apps back if the providers change or go insolvent? So some examples, and this is going back, EMC shut down Atmos, Vaultscape shut down, Iron Mountain and Certus got out of the cloud business. And there was actually an article from 2011, but it's still applicable on what happens to data when your cloud provider evaporates. Please have a plan for that. So the next one is really talking about how do you get data into the cloud, how do you get data out. Service level agreements are no different to the kind of service level agreements you should have today. What's covered? The web, data, all of it. When you're dealing with a cloud provider, you need to be fairly specific about what their service level agreements guarantee you. Are they going to guarantee you that your web applications will work? Or are they just going to guarantee you that the database will be up, but no guarantees beyond that? And make sure that they specifically explain what they mean by an outage. Because sometimes their outage is related to specific database servers, but not anything else. Again, lots of things to think about. So CRN published an article called The 10 Biggest Cloud Outages of 2024 So Far, and this came out in late July. And as you can see, there's been a significant number of them. One with Oracle, there was been quite a few Microsoft outages. In February, Google Cloud went down. There was a big AT&T outage in February and another one in May. And the FCC's actually been getting involved in those. Comcast went out in March. And then we have the major Cloudflare issue that took thousands of websites and businesses down back in April. And in July, we had the massive CrowdStrike one, which took down millions of Windows systems and impacted basically all of us. So be aware that these are happening and that you do need to plan for your business, whether it's you being in the cloud or things like your email systems and other applications being in the cloud. Make sure you understand what the impact would be of a full outage, because they're happening more and more. If you want to check on cloud outages, you can look at the Google Cloud Outage Detector. And this is going back 2019, 2020. You can see there are a number of outages, including Amazon EC2. And actually, McAfee published a report on cloud adoption and risk. So that's another report that's well worth looking at, because it was quite frightening that 69% of CISOs actually thought that their cloud providers would keep their data secure. I know 2011 was a long time ago, but I wanted to bring up this Amazon outage because it explains why you need to understand your SLAs and why you need to understand the disaster recovery. So in this case, the Elastic Compute Cloud did not go down. The relational database service did. The actual SLAs only covered EC2. It didn't cover any of the data services. So because EC2 was up, the people who were in the cloud had no comeback against Amazon for the fact that they couldn't get to their data. So great, they could get to the website, but they couldn't get to any data and couldn't do any business. And the other piece of that was there was different options for how you signed up for disaster recovery, whether it was local, regional, or east or west coast. And they had different price levels. A lot of people signed up for local, and unfortunately, the thing that caused the problem took out the region. If they had had west coast coverage, they would have still been able to run. So make sure you understand the SLA itself and also what your disaster recovery options are. When you're looking into software as a service, understand that those companies actually have their own set of legal risks. And Founder Shield actually did a nice blog on what those were. But they're typically talking about cybersecurity data breaches, intellectual property infringement. If I'm a software as a service and someone that's using my stuff breaches someone's intellectual property, who's responsible? They've also got to think about things like system interruptions, system failures, compliance regulatory changes, and contractual liabilities. And so one of the things that's becoming fairly popular now is SaaS insurance. And there are companies that offer insurance against data breaches, cyber attacks, system failures, and compliance issues, among other options. That may be something if you're moving into a software as a service environment or providing one that you want to look into. If you take nothing else away from this presentation, take away the fact that you need to design for cloud and you need to design for failure within the cloud. So making sure that from a physical perspective, they've got redundant N+1 hardware and software that allows you to move things such as vMotion or LPM, PowerHA or some kind of GLVM equivalent that actually does high availability. Making sure that they have proper virtual resources that are redundant and understanding the availability zones so that for doing failover, whether it's regional, etc., you can failover. And then what is the ability to survive a total loss of a cloud provider? These are all things that you want to make sure that you're designing into your cloud environment. And this is a list of just some of the criteria you may use for picking a cloud service provider once you've determined that you can move something into the cloud. So you could be looking at certifications, technologies, what's their roadmap, what are their policies on security and governance, what their SLAs look like, how reliable are they, what's their migration support, and that's for getting into the cloud, but also what's their migration support for getting out of the cloud if you decide to leave, and are you locked into that vendor? And then how healthy is the business? What's their company profile look like? Again, these are all criteria that you have to figure out which ones are really important to you, and you need to rank them. And this slide is just stressing the fact that the cloud is not the answer to you not understanding your environment. It's really important that you understand what you're putting up there so that you're able to run your business more efficiently. And I thought you might enjoy these 4 memes that basically are talking about a few things to do with cloud. And I want to add some thoughts about how the cloud can actually help. If it's properly implemented, the cloud lets you grow at your own pace without the heavy upfront costs of fleshing out a full technical environment. You can get the flexible rapid growth or scaling that you may need, and of course you only pay for things as you use them. They can be flexible. They can provide disaster recovery as a service, so maybe that's what you start with. Maybe you move your DR environment in there and test it out and see how it works. And then later on you may decide to put development and testing or the other way around. And again, you can choose your deployment. You can select your systems, your cores, your network. And you can have IBM or another company fully manage it, or you can use self-service where you manage it yourself. So cloud can be extremely flexible when it is properly planned. And just a few final thoughts. Cloud is here to stay. If it's done properly, it can be implemented safely and securely. But one of the critical things is planning ahead, but also understanding networking, because a lot of the conversations about the setup are going to be on networking if you're doing IaaS or PaaS. You need to understand the backup and disaster recovery options and what happens in those situations. Also understanding what support's provided and where it's located. And I've mentioned it multiple times, you need to know where your data and applications are going to reside. Lastly, it really is important that you don't just have a how am I going to migrate to cloud strategy, but you also need to have an exit strategy. So make sure that you think these things through, and you should find that a migration to cloud should go very smoothly for you. So I'd like to thank you for your time, and I hope you found this to be beneficial. I have the link here for a copy of the presentation, and that presentation handout has a few extra slides that have some links that you may find useful for looking at different cloud environments. So again, thank you, and have a really good week.